Let's review covalent bonding. So covalent bonding, the word co, or the prefix, means together or joint or jointly, where valent or valence electrons are the outermost shell. So this is the sharing or using jointly of the valence electrons to make an octet. If you take a look at the carbon and hydrogen bonding here, there are two nonmetals. The electrons for hydrogen are in red. The electrons for the carbon are in blue. So carbon has 4 electrons. It wants to get to 8, so it will share the electrons with the hydrogens to make 8. And the hydrogen wants to have 2 because it only has 1 orbital. So covalent versus ionic. Ionic bonds involve metal and a nonmetal. Covalent bonds involve 2 nonmetals. Let's look at this video here.
Covalent bonds. In this video, you are going to learn about covalent bonds, how they are made, and how they form. If you haven't seen it already, first have a look at our video, Structure and Bonding. Only the noble gases exist naturally as single atoms. All the other elements of the periodic table have partially filled valence shells, or outer electron shells. Atoms bond by swapping or sharing electrons in their outer shells. When very different atoms react, like metals and nonmetals, they normally swap electrons. This is ionic bonding. But when similar atoms react, like nonmetals combining with other nonmetals, they share electrons. This is covalent bonding.
All right, so covalent bonds involve the sharing of electrons between 2 nonmetals.
Nonmetals are found on the right-hand side and upper part of the periodic table. Some common nonmetals are carbon, nitrogen, oxygen, and the halides. They have shells of electrons that are normally half or more than half full of electrons. Since they have a strong attraction for a few additional electrons, it is energetically unfavorable for them to lose electrons, so they share electrons by overlapping orbitals. This makes a bonding orbital, or covalent bond, that contains 2 electrons.
So the side of the periodic table which would include nonmetals is the right-hand side. Nonmetals are highly electronegative and attract electrons. That is true. They like to gain electrons. The only way to gain electrons is to share with 2 nonmetals. They both want to gain. Nonmetals tend to gain electrons metals want to lose, all metals want to gain. So sharing, since we have two nonmetals involved, neither element will give up their electrons. Both are holding tight. So to achieve stability, they need to share valence electrons. So unpaired valence electrons have the sharing of valence electrons here. So unpaired valence electrons are what cause the sharing. The elements are sharing just a few valence electrons. The elements are trying to achieve the octet rule. Remember, the octet rule is either 8 or 2. The Lewis diagrams have room for the pair of electrons for each side of the element symbol. Nonmetals will share their unpaired electrons. Note that the two ways to draw the final molecules, circles or lines. After covalently bonding, how many valence electrons does each atom have? Well, this particular case, hydrogen would want 2, all other elements would want 8. Which electrons are involved in covalent bonding? Valence electrons. What does a single line represent in the Lewis dot diagram? Okay, so if you notice, the lines have replaced 2 electrons. So 2 shared electrons, and that's called a single bond. Single bond, 2 shared electrons. How do we represent atoms sharing 4 electrons? Remember, each bond, single bond, has 2. So if we have a double bond, we have 2 lines and 4 electrons. So 2 lines. So a triple bond would be 3 lines and 6 electrons. So let's go name covalent compounds. We still add the IDE to the end of the second element. We add prefixes to indicate how many atoms on each element are involved. So mono for 1, di for 2, tri for 3, tetra for 4, penta. So the very similar to geometry. Hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. So here's some examples. So nitrogen monoxide, remember the first element does not have to have mono in it, but if we get to 2 of the first elements, like we have to use a prefix, so dinitrogen trioxide here. Which of the following matches dihydrogen monoxide? So di means two, so two hydrogens and one oxygen. So we're going to be talking about water, H2O. This formula matches dichloride, tetrabromide, dichloride 2, and tetra, 2 chlorines and 4 bromines. Name here. So 2 nitrogens, 3 oxygens. So di, we're looking for di here, and tri here. Now be very careful. It's not this one because we don't have an ide on the end here. So dinitrogen trioxide is here. All right, that's the last slide. Thank you for sharing or participating in this video.